Okay, Algebra 1, here we are again. This is Friday's lesson, lesson 101, and today we're really going to talk about the Pythagorean theorem. There is a little bit here about what we call an angle. It's not terribly complicated, so just read through it and understand that people in Europe consider it or think about it slightly differently than we do. But the main point here is that an angle is formed by two half lines or rays that are in the same plane and that have a common endpoint. That's pretty obvious. And we're talking about this inside portion here. You could also talk about an angle being this portion here on the outside, but that's not really what this is all about. So down here we have a little thing that shows that two perpendicular lines that intersect create 90-degree angles, and this is the basis for the Pythagorean theorem. No, it's not. It's the basis for knowing that the interior angles of any triangle equal 180 degrees. Because if that one is 90, then when you create your line across here or here, however you want to draw it to create a triangle, the other portion these two angles must add up to 90 degrees. All right, up here we have the more diagrams of how the interior angles of different triangles add up to 180 degrees. I think that's pretty easy for you guys. This triangle, the long side is called the hypotenuse. The short sides are just sides or legs, but the term hypotenuse is important. Yeah. As we go on here, 101b, the Pythagorean theorem, this is where knowing which one the hypotenuse is really important. So you learned this last year, but again, the idea is that the square drawn on the hypotenuse of a right triangle, the area of that is equal to the sum of the areas of squares drawn on the two legs or sides. Okay, so as you read through this, it should make sense. But if you saw that this triangle is 5, or sorry, this hypotenuse is a distance of 5, you would say 5 times 5 is 25. And then this distance is 3, so 3 times 3 is 9. And this distance is 4, so 4 times 4 gives you an area of 16. And that means that 5 squared, 25, is equal to the 3 squared plus 4 squared. So 25, this side, the area of this side equals the area of the triangles created by adding these two areas together. I think you guys can handle all that, but read it over again. So the basis, the Pythagorean theorem says that a squared plus b squared equals c squared. C is the length of the hypotenuse, and A and B represent the lengths of the other two sides. Now, the way this gets interesting or more complicated is by using the information we've been learning in the last couple lessons to do a little bit more with triangles and with formulas. So the square of the hypotenuse equals the sum of the squares of the other two sides. So if you know that 5 squared equals 4 squared plus a squared in that triangle, you would be able to say that 25 equals 16 plus a squared, which would tell you that 9 equals a squared. And given the difference of two squares theorem that we just learned, we could say that a squared equals 9, which means that a could equal either positive 3 or negative 3. But since we're talking about the measurement of a side of a triangle, negative 3 makes no sense. Therefore, we can determine that a equals positive 3. The next several of these equations or examples just build on the complexity of that idea a little bit. In this triangle here, you can see p is your hypotenuse, so p squared should equal 4 squared plus 5 squared. So they set up the equation like that. They say that p squared equals 41, and then you would want to find p, so you need to take the square root of p squared. So if you take the square root of p squared, you should take the square root of 41. They kind of do an extra step here, writing it this way. If that helps you, you're welcome to do that, but I sort of skip that step, and I just say, I know I need the square root of p squared, so I need the square root of 41, and I jump right over here. P equals the square root of 41, or p equals negative the square root of 41, but again, this is the length of a side, so it's not going to be negative. So p equals square root of 41. For k, we do the same thing here. It just looks more complicated, but our equation should be the hypotenuse squared equals the legs or the sides squared and added. So the square root of 61 squared equals k squared plus 5 squared. And you would simplify the square root of 61 squared by just saying 61 equals k squared plus 25. Then you would finish up here by saying, what is the square root of, sorry, let me jump back. So this gives you 36. It's 36 equals k squared. So if 36 equals k squared, you could say, what is the square root? You need the square root of k and the square root of 36. So the square root of k is k, the square root of 36 is 6. So k equals 6. Okay, this one, example 101.4, is slightly more complicated, and I wrote it on the board just to remind you guys of how to take the square root of a large number. Okay, so it's basic. It's just m squared equals 12 squared plus 8 squared. Okay, so then you get the m squared equals 208, and what do you do with that at that point? How do you get 4 times the square root of 13? So let me look over here on the board with you and just remind you. When you're finding the square root of a large number, you want to go ahead and factor that number down. So you start with the 208, and I use my upside down division symbols. Divided by 2 gives us 104, divided by 2 gives us 52, divided by 2 gives us 26, divided by 2 gives us 13. So this is all still under the square root of 2 to the 4th times 13. But 2 to the 4th is 16. So my answer is the square root of 16 times 13. And my 16, I can take the square root of, which is 4. So 4 times the square root of 13 is the answer of that, which shows up right there in your book. So hopefully when you see that, you won't be terribly confused. And hopefully this is helpful as you guys work on this lesson on Friday morning.